Hi, in this video we will see how to install NCBI BLAST in your local machine and how to create a database from your nucleotide or your protein FASTA sequences, and then we will run a query to get the or to retrieve the uh, results from our created database. So first of all we need to open terminal, and actually there are two ways to install. The first one is very easy, but if it is not working for you, you can uh, adopt the second one method. So first of all, uh, we have to type here sudo apt update, then type your password and press enter. Wait for a while and then type sudo apt upgrade, then press enter. So it may take some time for your systems, but it is not taking uh, much longer for me because I have already used these commands. So now the command for our uh, now the command to install NCBI BLAST is sudo apt install NCBI dash blast plus, and then press enter. Here press or type capital Y and press enter, and the packages are getting downloaded, so wait for some time. So we have installed database, and to check whether the database is present, it is installed or not, we can type here blastn dash version, press enter. Then we can see that we have our tool ready to be used. Now that we have installed the database, we can create. So first of all, write here clear to clear the outputs of previous commands. Now I will show you something. So for example, I have these FASTA files. These are the proteome. This one is the proteome from one organism. This is the proteome from another organism. In a similar way, these are the different proteomes from different organisms, and each one of them is containing multiple FASTA sequences. For example, I will show you this one. So this is my FASTA file. This is my first FASTA file, and this contains a large number of sequences. But here I want to create a database of all these protein FASTA sequences, and I will use this file as query against my database. So how to create a database? Now that I have these files in my home and YouTube directory, so in my terminal I will type cd and YouTube and press here ls, and you will get the file names that I have there in this folder. So if you are new user to command line, you can directly come here and open in type here, you can select the open in terminal, then type then click on this. And now that we have all the files here, first what we need is to combine these files. We will combine these 5 files. So to combine these files, simply type cat ep, because these all files are starting with ep, so, and this one is not starting with ep, so we can type cat ep star, and we will save the content into a new file. For example, I am writing here some name for my file. For example, database FASTA or database.fasta. This is not a database, but I can type here more relevant name, all sequences.fasta. So now press enter and list all the files. Now you can see that we have all FASTA sequence. We can see the content of this file by typing more all FASTA, all sequence.fasta. Now press enter. We can see that we have all the sequences from all other files which are starting with the EP. So now we will create the database. So what we have to type here, make blastdb. So this is the command to create a database, but here we had to provide some parameters, for example in. So to create a blast database, we have to input some file. For now our file is this one, so we will type here all sequences.fasta. This is our in file. Now we have to specify the data type dbtype. It means that we have to specify the data that this database is for protein sequences or for nucleotide sequences. If this database if this FASTA file contains nucleotide sequences, then you have to type nucl, but for now these sequences are protein sequences, so we have to type here prot. Then we can type here hash underscore index. So this command is optional, you can use, or it depends on you. If you want, you can use. If you don't want, don't use it. Use this command. This command will create a hash to your FASTA files, and it will speed up your query search. When you give the query, you will get the sequence result faster. But this command also takes some more memory from your hard disk, so it depends on you. You want to run this or not. For now, I don't want to use this one. For simplicity, I can write here out. I want to out the database, for example all. So this will be the name for my database, all proteins. This is the name for my output database. The database that will be generated will be known as all proteins. So, and we can specify one more option here, that is max file size file underscore sz, and then you can specify the 4 GB. The default is 1 GB. What this means is the maximum file which will be created after your database. When your database will be created, the maximum file size would be 4 GB. So if you don't give this, the file size will be 1 GB, which is default value. Now you can press enter. So for example, here is some problem. Now what is the problem? Yes, the max file size, this parameter is here, so we have to give one underscore here. So after that it will work. For example, this was our command, so max underscore file dot underscore size. Press enter. Now that we can see that the database has been created, and the database name is this all proteins. This is the directory where the database is created. It means this is the same directory where we are now working, and this is the title of the database. So we can see here, type ls, press enter, or type clear. Now type ls. You can see that we have created new files. These are the database files. So actually we have created the database. Here you can see that these are the new files, and now we have our database created from all these files, and we will use this query to access the database. So what we have to do, type here blastp, because we will give the query sequence which is protein FASTA sequence. So if you have nucleotide database and you want to give a nucleotide query, you can type here blastn. but for now we are using blalstp, and then type query dash query. Now specify your query file. For example, this one is our query file here, so type the query file name and then specify the database. For example, here our database is all proteins, and now we can specify the output file name if you want output, but for now I will not use out. I will show you the results, but press enter, then these are the results, but these results are in outfmt0 format, and these are not stored anywhere. So to store these all results, we have to specify the dash out parameter, and now we can give the name of output file. You can type here anything. I am typing here result.txt. Now run the command. So the blast command is successfully executed. Now list ls, you can see that we have results.txt file here, or we can also see this file here. So we have generated this file. This is the result file after blast results. So you can see the different results. Our query file was this one, and the sequence that we get, which is most similar, is this one. The second most similar sequence is this one. The third most similar sequence is this one, and the results, these results are in outfmt0 format. This is the default format, but you can specify the different format. For example, outfmt6. This, if you want to generate tabular results, so you can type here result1. Now you will have the tabular results. Now press enter, and now see that we have, this was the old file, this was the new one. Now open this file. So now this is our query file, and this was the subject sequence. So this is the query, and these are the subject sequences which we get after the blast results. And you can search on internet that what is the meaning of this column and this column. This is the similarity, this is the bit score, and this is the e value. For example, you can go here and search blast out fmt6, and now go to the first link. You can see that the first thing is query sequence. The second column in this table is subject sequence. The third thing is percent identity. Fourth thing is length. Then fifth thing is mismatch that are present in both of the sequences. Then gap open, number of gap opens. Then query starts, query ends, subject starts, subject end, e value, and bit score. So this is the tutorial for today, but for second part I will show you that how to install blast if the first one is not working for you. So here, this is the website. From here you can download the tool for your installation. For example, now we are using Linux. You can download this file along with this one. For Linux system you can download this. For Windows you can download these files, these two files, and for Windows it is very easy to install. And for Mac system you can use the universal version, and according to your system you can get from this website. So for example, for now I will download this one, but this file will take longer because this is 246 MB inside. So I will stop here. You can read the MD file, and it will show you that how to install this tool. This is very easy thing. This is not difficult. but for most of you the first command will work, that is sudo apt install NCBI BLAST plus. So this is the today's tutorial. Thank you.